I'm Marcus Wise, and I would like to explain conformity in the mind of an engineering major. When I think of conformity, I think mathematical functions that have symmetry, and particularly I think of trigonometric functions. I've done some research on UALR.com and wolframalpha.com and came up with a history of trigonometric functions. They were originally designed to explain astronomy, went back before the 16th century when people believed that Earth was the center of the solar system. We would have to use what we now know as trigonometric functions to explain and calculate the positions of other celestial bodies in respect to the Earth. And through many years of research, it's developed into more and what we now call trig. So let's look at some of the trigonometric functions that we use today. There are 7 functions: sine, cosine, tangent, cosecant, secant, and cotangent. Each of these represents a unique graph and a unique purpose. However, they are not unique in the terms in which they can be written. In fact, they can all be rewritten in terms of each other through different properties and identities. So just looking at sine theta, we can rewrite it as plus or minus the square root of 1 minus cosine squared theta, plus or minus tangent theta over the square root of 1 plus tangent squared theta, 1 over cosecant theta, plus or minus the square root of secant squared theta minus 1 over secant theta, plus or minus 1 over the square root of 1 plus cotangent squared theta. And the same goes for all the rest of the 7 functions. And these are just the most simplified forms. There are, in fact, in theory, infinite different ways you could describe each 7 different functions. Now I'd like to explain the conformity in the graphs. For easy purposes, I've printed off a graph of a tangent function. And as you can see, the tangent function is a line between negative pi over 2 and pi over 2 that goes through the origin. However, it will never reach the asymptotes of negative pi over 2 and pi over 2. This is a very great way to portray conformity, as the tangent function repeats itself infinitely, each function never reaching the limits or the asymptotes by which they're separated, and they all represent the same curve. The same goes with other trig functions, where they all just represent different curves, essentially, or different lines that bend but never reach the asymptotes that they're next to. I think of this in correlation to conformity, and I think it's really beautiful that conformity exists in even math. So, yay, conformity.